Hello class 10th. Today our topic in this video is about the properties of acids, that is its physical properties as well as the chemical properties. So it is properties of acids. First we are doing physical properties of acids. Like acids, they are sour in taste. We all have tasted vinegar. Vinegar is sour in taste. So all acids, they have sour taste. And we have done, they turn blue litmus to red color. Next, very important property, they are corrosive in nature. They will eat up the material like wood or even the skin. So they are corrosive in nature. Next is they are electrolytes. Electrolytes means they ionize in water. That is, they ionize in water, so they will conduct electricity in water. That means here you can write they conduct electricity when dissolved in water. These are physical properties of acids. Now we are doing first activity before taking up the chemical properties. This activity is about, do all substances which contain H in them, hydrogen in them, are these acids? So our activity is just to check conduction of electricity. By acidic solutions. So if substance will be acid, then it will conduct electricity, and if it is not acidic in nature, it will not conduct electricity. So for this activity we are taking some solutions like glucose. Formula of this is C6H12O6. So hydrogen ions are there, hydrogen atoms we can see in the formula. So we have to see whether that glucose will conduct electricity or not, glucose is acidic in nature or not. The next is alcohol. One example of alcohol I am taking is the methyl alcohol, methanol. This also has hydrogen in its formula. So let's see this will conduct electricity or not, this is acidic in nature or not. The next example we will take is of hydrochloric acid. HCl. Next we are taking is sulfuric acid, H2SO4. So from this activity we will come to know whether the substance is acidic or not, though the hydrogen atoms are there in the formula, but are these hydrogen given out as H plus or not? For this we are taking a beaker. In beaker, we will take a cork, a rubber cork we will take here. And in the rubber cork, we have to fix two nails. And these nails we are connecting with the battery. And the battery that we are taking is just a 6-volt battery. And there should be a bulb also here. Along with this, there should be a switch also to pass on the current. So this is a bulb. This is switch, beaker, nail. This is cork. And this is a 6-volt battery. Now the four solutions that we have mentioned, that is glucose, alcohol, hydrochloric acid, sulfuric acid. One by one we have to add the solutions in this. So let's say first of all we are taking here dilute HCl in this. What we are taking here is dilute HCl, let's say. So I'm labeling this that the solution, for example, we are taking is dilute hydrochloric acid. Now, after this, we have to start this experiment. That is, we have to switch on this. When we switch this, what will happen? The current will pass. If the current will pass through this, then the bulb should glow. That means if this HCl will dissociate into ions, that is, it will produce H plus ions on dissociation, then only ions will conduct electricity. If ions will not be there in the solution, then the electricity will not be conducted and the bulb will not glow. Now we are taking how many solutions here? 4 solutions we are taking. So I'm making a table of these 4 solutions. First is we are taking a sample solution. And these are hydrochloric acid. Then sulfuric acid after this we'll take in this. Then let's say glucose solution we will fill. And after glucose we'll fill alcohol solution. So these 4 sample solutions we are taking. Now, observation here. What we will observe when we will fill this beaker with these solutions, what we will observe. And then what will infer from this, what result we will make out from that observation. So when we will fill hydrochloric acid in this, the bulb will glow. So if the bulb will glow, that shows that it is conducting electricity. So it conducts electricity. Similarly, when sulfuric acid is filled here in this beaker, then also bulb will glow and we'll say that electricity is conducted by this. But when we'll fill the glucose solution, the bulb does not glow. And even in alcohol solution, bulb does not glow. That means they do not conduct electricity. These 2 solutions, they do not conduct electricity. This will infer from this experiment. So we will conclude this by saying this shows that HCl and H2SO4, hydrochloric acid and sulfuric acid, they actually ionize in water. They break in water to form ions. Which ions? H plus ion from HCl and Cl minus, from H2SO4, H plus and sulfate ions they will form, which make acidic solutions conductor, because I told you conductor of electricity here are ions. If ions will form, then only that substance will be conductor. So this shows that because they are breaking up into ions, so this make the acidic solutions conductor in nature. Like HCl. Remember, you have to dissolve that in water. Water is required here to dissociate this into the ions. So this will dissociate to form H plus ions and chloride ions. Similarly, if H2SO4 is here, this also in water will dissociate to give the hydrogen ions and sulfate ions. Like I mentioned here. On the other hand, glucose and alcohol, they do not ionize, they will not break. Hence, these are not conductors. So what we'll conclude from this whole thing? The conclusion that we are making from this whole thing is, thus, all compounds containing hydrogen, do not ionize to give H plus ions and hence are not acids. Example, like we have done now, glucose and alcohol have hydrogen, but these 2 are not acids. So this is about this activity. Now moving on to the next part, chemical properties of acids. We'll cover up 4 chemical properties of acids here. first chemical property of acid is reaction with metals. When we react acids with metals, what will happen? See, metals like zinc. To this, when we add acid, this formation of zinc sulfate salt, and plus there is evolution of which gas? Hydrogen gas. Similarly, if we take hydrochloric acid, then also there's formation of salt, zinc chloride, and there's evolution of which gas? That is the hydrogen gas. Can we write in a simple way that acid, when reacts with metals, this formation of salt and evolution of which gas? Hydrogen gas is there. So this happens whenever acid reacts with the metals. But for this we have an activity now. That is reaction of sulfuric acid we are taking with the zinc granules, or we can take the hydrochloric acid with the zinc granules. For this activity, we are taking a test tube. In this test tube, there's a cork that we have to fit in the mouth of the test tube. Before that, we have to pass a delivery tube through that hole of the cork, and through that we are passing this delivery tube. And this delivery tube, the other end should dip into the solution which we are taking in a trough. That solution is a soap solution. Which solution we are taking here is a soap solution we are taking. So this is our apparatus that we need for this activity, and this we are holding with a stand. This is a stand. So what we have to take in the test tube, first of all, before putting up this cork, we have to take the zinc granules here. What we are taking here is the zinc granules we are taking. Zinc is a white color metal. And then in this we will add dilute sulfuric acid. What we add into this is a dilute sulfuric acid or dilute hydrochloric acid we'll add. And you have to observe one thing more, the surface of the zinc metal also you have to observe. So when you will see the surface of this metal, what you will find? On the surface of this metal, you will see some bubbles here. On the surface, what you will find? There are some bubbles forming on the surface. And these bubbles only are evolving out. They only are going out. And when this gas, bubbles means some gas is forming here. When these bubbles, they come this side and pass through the soap solution, then there will be bubbles of the soap solution formed. And this gas will be entrapped inside these bubbles of the soap solution. Inside the soap bubbles, there is a hydrogen gas. And then what we will do is, here we'll light up. This gas we have to light up. We'll bring a burning candle near to this. When we bring a burning candle near to this, we'll see that this gas will burn and there will be a pop sound also. This gas will see this will burn. And there is a pop sound also. So if the pop sound is there and the gas burns here, this indicates that the evolved gas is which gas? This is a hydrogen gas. So experiment here is, this is a test tube. This is which metal? Zinc metal. And in this we have taken sulfuric acid. Then this is a delivery tube. Here we have a soap solution. The question here can be that why we are using a soap solution? We can take simply a water also. Remember, hydrogen gas will not come out through the water. So when this will bubble through the soap solution bubbles will form and hydrogen will be entrapped inside. Like this, the hydrogen can come out. So you can say that this is actually a soap bubble filled with the hydrogen, and this is the hydrogen. You can label burns with pop sound. This is this part here. This is a cork, and this is a stand. So our observation is the bubbles formed in the soap solution, and then we'll bring a burning candle near a gas filled with the bubble and record the observations. So the observation is that this gas will burn with a pop sound on bringing a burning candle near the bubbles. This indicates that the evolved gas is a hydrogen gas. Now, one thing more we have to check here, the color of the zinc granules here that we have taken, the zinc metal. I told you this is white color metal. We have to check the color of these granules also after the reaction, and we'll find that these granules, they will be of black color now, and they will be dull in appearance. The zinc metal, will find that zinc metal after reaction will become black and dull. And touch the test tube also, and we find that this is highly exothermic reaction, because we'll find that the test tube is very hot. So these two more indications are here. In this after experiment, we can check the color of the zinc metal, that will become black and dull in appearance, and the test tube will be very hot. That indicates that the reaction is exothermic in nature. So this is about the first chemical property of acids, that is reaction with metals. Moving on to the second chemical property now. The second chemical property, we are taking reaction with metal carbonates and metal bicarbonates. Acid reaction with metal carbonates and metal bicarbonates are also called hydrogen carbonates. This is when, example I am taking, acid reaction with carbonate like sodium carbonate, or we can take sodium hydrogen carbonate, also called sodium bicarbonate. In both the cases, the reaction will be same. There's formation of salt, evolution of carbon dioxide gas, and formation of water. Even in this case, the reaction will remain the same. Only difference will be in the balancing. In this case, 2 HCl we have 2 NaCl in this case, while this will remain like this only. So this is about the two reactions taking place of acid with the sodium carbonate and with sodium bicarbonate. So can we conclude that it's acid, then metal carbonate, or we can take metal hydrogen carbonate in a reaction? Then what we get is salt, water, and this formation of carbon dioxide gas. This will happen. Now one activity for this thing is, that activity is reaction, same thing only, reaction of hydrochloric acid with sodium carbonate and sodium bicarbonate. For this activity, we are taking two clean test tubes labeled as A and B. I'm showing this with one test tube only because same result we'll get in the other one. So we are taking a test tube, and the test tube has a cork, and there are two holes now in a cork. Through one hole, a thistle funnel is passed. This is thistle funnel. And in this test tube, we are taking the sodium carbonate. Sodium carbonate, this is white color only. And what we have to add to sodium carbonate? We have to add HCl. So HCl we'll add afterwards. First we'll set up this apparatus. Then through the other hole will pass delivery tube. And the other end of this delivery tube will dip into a test tube which has lime water in it. Lime water is calcium hydroxide. It's transparent, freshly prepared is taken. So this is actually a lime water, that is calcium hydroxide solution we will take, which is also called lime water. This is delivery tube, this is thistle funnel, this is cork, and this is sodium carbonate we have taken. Now we'll just fix this apparatus using a stand. This side we are taking a stand. Cork. Now after setting this apparatus, what we will do is slowly and slowly through thistle funnel, we will add hydrochloric acid to this. When hydrochloric acid is added, we will observe some bubble formation here. Bubble formation means some gas is evolving here because of reaction of the sodium carbonate with the hydrochloric acid. This is HCl, delivery tube. This is also a test tube. The gas evolved is a carbon dioxide gas. The gas evolved here is a carbon dioxide gas. See, this gas that is evolving here is which gas? Carbon dioxide gas. Thistle funnel. This part is cork. Thistle funnel already I have labeled here, so there's no need for this part. Okay, now this carbon dioxide that is coming out here, it comes into this part and goes into the solution. What will happen to this solution when the carbon dioxide gas goes into this solution? We'll find that the solution will start changing to milky color. A milky color will come here, milkiness will come here. Why this milkiness will come here? The observation is that this is changing to milky color. Experiment part is clear to you, hope. We are taking sodium carbonate, HCl is added. When HCl is added, the two will react and the carbon dioxide gas will evolve. That carbon dioxide, when comes into this test tube which has lime water, the lime water will start changing to the milky color. This is our observation. Now what will infer from this? Inference that we'll make from this is, inferences, it has reacted with the acid, has reacted with the sodium carbonate, or if we take sodium bicarbonate, then also I told you reaction will be same only. We have written the reaction already. This carbon dioxide gas is evolving. This carbon dioxide gas is reacting with the calcium hydroxide, that is lime water. And why that milkiness is here? Because actually when the two they react, this formation of calcium carbonate. Calcium carbonate is of which color? That is of the white color. So white color is there because of which the calcium hydroxide turns milky. But note, very important thing here. If excess of carbon dioxide goes into the lime water, what will happen in that case? Calcium carbonate and water is formed. But if excess of carbon dioxide goes into this, then calcium carbonate changes to calcium hydrogen carbonate. Then the calcium carbonate will start changing to calcium hydrogen carbonate. This will not be there. Instead of this, now there will be calcium hydrogen carbonate, and because of that the milkiness will disappear, because calcium carbonate only is a white color. This is again colorless, so milkiness will disappear here. That is the important point. If excess of CO2 passes through lime water, the milkiness disappears. This is the second property. Now we do the third property of acids, that is reaction with bases. When acids they react with the bases, they form salt and water. And these reactions are called neutralization reactions. Neutralization means the acid and base, they are neutralizing each other, and hence these reactions are called neutralization reactions. Example of this reaction is acid like HCl, base NaOH. When they react, the salt formed is NaCl and water. Which salt is formed here? That is NaCl. Another example of an acid, sulfuric acid, reacting it with the sodium hydroxide base, it forms a salt, now sodium sulfate, and plus there is formation of water. To balance this reaction, this will be 2 and this one will be 2. Now the investigation to understand that neutralization, how it takes place when the acid and base are reacting with each other. One activity we are taking for this activity is for reaction of acid and base. See, first of all, we are taking a test tube. In this test tube, we are taking sodium hydroxide. A base is taken here. Which base we are taking here? That is sodium hydroxide. This is a base in this. And then to this base, we are adding here phenolphthalein. What we are adding here, just 2 drops of phenolphthalein will add into this phenolphthalein. And we know phenolphthalein in a base that shows which color? Pink color. So when phenolphthalein will go into this base, this whole thing will change to which color? A pink color is there. So we know that this is a base. Now what we'll do is, after this, slowly and slowly in this we will add an acid. What we'll add to this test tube now is base, and there is phenolphthalein added to this, so this is pink in color. So our next step is we will add an acid to this. What we are adding here is acid. Slowly, drop wise drop, we'll add an acid to this till you will see the color disappears. Till the color disappears, that much amount of acid we have to add. So there's a base in this, and plus now what we have added, an acid to this, and we'll see that pink color will disappear. From this we'll get this thing, and then when we'll add acid, the color will disappear. And now what we'll do is, after this we will add a few drops of base into this, just 1 or 2 drops of base into this. When we add, again what we'll find, that this becomes pink in color. Now this activity tells us that when the solution is acidic, when it is basic, and when it will neutralize. See, initially it is base only because phenolphthalein in a base shows a pink color. And then when we add acid to this, what will happen? Acid and base will neutralize. Neutral solution will form and it will become colorless again. And then again when the base is added here, what will happen? Phenolphthalein and base. In the base, the phenolphthalein again will show which color? That will show the pink color. So this is our inference from this thing, that is HCl and NaOH. they have reacted, and what they have formed is a neutral solution, because of which the color will become colorless. And now when the NaOH is added here, again what will happen? The pink color will reappear, as now the medium is basic in nature. So after this, we are moving on to the fourth property of acids: reaction with metal oxides. Metal oxides, remember, they are basic in nature. So when acid reacts with these metal oxides, I'm writing here that these metal oxides actually are basic in nature. So just now we have done acid and base. Whenever they react, what we get? Salt and water. So again, there's formation of salt and water in this. Example, acid is HCl, metal oxide, let's say copper oxide we are taking here. They react and a salt formed here is copper chloride, along with the formation of water. One more example of this is, we'll take HCl, but now metal oxide I'm taking is aluminium oxide. So the two will react and this formation of salt, aluminium chloride, along with formation of water. Now to balance this equation, this is 6, this is 2, and this is 3. Again, now the investigation for this thing, the reaction of acid with the base. I'm taking this one, HCl and copper oxide reaction in this activity. So our activity here is reaction of dilute HCl with copper oxide. Now for this activity, we are taking a beaker. In this beaker, we are taking copper oxide. It's a white color substance. So this is copper oxide. And to this we are adding slowly and slowly dilute HCl. So when dilute HCl will add to this, it's like this. But now the two will react with each other, and after reaction, what we'll see? The two will start reacting. This is dilute HCl we have added. It has reacted with the copper oxide, and we will see that copper oxide here has reacted, and this whole solution now, this will become blue in color. That means some new substance is formed here. So what happens when the two are reacting with each other? It is HCl reaction with the copper oxide, and this formation of a salt, copper chloride, along with the formation of water. This copper chloride is blue in color. That means now copper oxide has changed to copper chloride. That is why this blue color will form. This is copper chloride solution in water that is formed, because of which the color is blue now of this solution. So this is about this activity and the properties of acids. Moving on now to the properties of bases. Physical properties of bases. In the physical properties, first is the taste of bases. Like we have done, acids are sour in taste, bases, they are bitter in taste. And when we touch the bases, they are soapy in touch, slippery, soapy in touch, and they turn red litmus to blue color. They are also conductors of electricity like acids, so conduct electricity, but again here in acidic medium, or sorry, in aqueous medium, in water. So when they are dissolved in water, then only bases will change to ions, and because of that they conduct electricity. So these are physical properties of acids. Moving on to the chemical properties of bases. There are three chemical properties that we will discuss. First is reaction with metals. Reaction with metals. Like acids only. When bases they react with metal, there's formation of salt with evolution of hydrogen gas. Now investigation for this, an activity to understand that there is evolution of hydrogen gas. So we are taking reaction of sodium hydroxide with zinc metal we can take here. Okay, now activity here is we are taking a stand here. Then we have a test tube. We are taking a test tube here. Under test tube we are taking a burner. And when we switch it on, there will be flame here. And in the mouth of this test tube there's a cork with a hole, and through that hole there's a delivery tube that will pass here. The other end of the delivery tube goes into a soap solution that we will take in a trough. In trough, what is filled up here? A soap solution is filled up here. And before setting this apparatus, in the test tube here, we will take zinc metal, that is a white color metal. So we are taking here a white color zinc metals. These are zinc granules that we'll take. So this is zinc. This is soap solution, delivery tube, and in this we will take the HCl. What we'll add to this is, like in acid we had added HCl, in this case we are doing the chemical properties of bases. So in this case we will take this as sodium hydroxide solution, and when the two will react we'll see the bubbles forming here. These bubbles are of which gas? These are of the hydrogen gas. So this hydrogen gas which is forming, it will come to this side through this delivery tube, passes through the soap solution and gets entrapped in these soap bubbles. And when we'll bring a burning candle near to this, what will happen? There will be burning of hydrogen with a pop sound. So hydrogen burns with pop sound here. This is burning candle. And these are the soap bubbles filled with which gas? Hydrogen gas. So reaction here that takes place is sodium hydroxide has reacted with the zinc granules and this formation of salt. Which salt is forming here? Na2ZnO2 along with the formation of hydrogen gas. So hydrogen gas is forming here or not, how we'll check this thing? So when this gas is coming here and when we'll bring the burning candle near to this gas, if this gas will burn with pop sound, that means the gas evolved is a hydrogen gas. Now the name of this salt that is forming here is sodium zincate. Name of this salt is sodium zincate. So this is the first property of the bases. Bases, when they react with metals, this formation of salt and hydrogen will form. Now the second chemical property, reaction with acids. Same we have done in the acids also. Reaction of acids with base. Now we are seeing reaction of the base with acid. This is one and the same thing only. Whenever the acids they react with a base, or bases they react with acids, this formation of salt and water. And these reactions are called which reactions? Neutralization reactions. Because the two, they will neutralize each other. Acid neutralize base, or the base will start neutralizing an acid. Example of this we can take is reaction of sodium hydroxide base with an acid like HCl, formation of salt NaCl and water takes place here. This formation of water and NaCl. Now the third chemical property of bases, reaction with non-metal oxides. When bases they react with non-metal oxides. In acids we have done reaction of acid with the metal oxides. Now here we are taking the non-metal oxides, and non-metal oxides are acidic in nature. Metal oxides are basic in nature. So we are taking a base. When this reacts with non-metal oxide, that is, it is reacting with an acid. So base and acid, when they will react, this formation of salt and water. Example now, the base we are taking here is, let's say, calcium hydroxide. And non-metal carbon, its oxide we are taking is CO2. It forms calcium carbonate along with the formation of water. The salt formed here is a calcium carbonate. So whenever the bases they react with the non-metal oxides, there is formation of salt and water. So this is a topic about the properties of acids and bases.